Today we're going to be learning lesson 5.2, proportions. We're going to start off with some vocabulary. The first thing we're going to go over is what is a proportion. So a proportion is an equation stating that two ratios are equivalent, meaning that they're equal. Two quantities that form a proportion are called proportional. Okay, so an example here is 2/3 is proportional to 4/6 because 2 times 2 is 4 and 3 times 2 is 6. The way that we read this proportion is 2 is to 3 as 4 is to 6. So this would represent that 2/3 and this would represent that 4/6. All right, let's go over some examples of determining whether ratios are proportional. So here we're asked to tell whether 6/4 and 8/12 are form a proportion. So I'm just going to rewrite them down here. Okay. And how do we get from 4 to 12? We multiply because we're getting a bigger number, and we multiply by 3. 4 times 3 is 12. Okay, then we have to look up here to see, does 6 times 3 equal 8? It does not. Okay, so no, these do not form a proportion. Okay, another way that you could solve this problem is reduce each of these fractions. Okay, so both of these can be divisible by 2. So we have 3 over 2. Both of these can be divisible by 4. So we have 2/3. Notice that these are not the same fraction, so they are not proportional. So that's another way we could have figured that out. Example 2 is going to be using a table to determine whether two quantities are proportional. So we want to know are x and y proportional. Okay, so if they're proportional, that means every single ratio in here, x to y, is equivalent to another one. Okay, so to get from 1/2 to 1, well, think about if you had 50 cents and you're trying to get to $1, you would multiply it by 2. Okay, so 1/2 times 2 is 1. Well, is 3 times 2 6? Yes, so that worked out so far. Let's try another one. 1/2, oop, I wanted to use a different color, sorry. 1/2 to 3/2. Well, 1/2 times 3 is 3/2, because 1/2 times 3 over 1 equals 3 over 2. Okay, so 1/2 times 3 is 3/2, is 3 times 3, 9. Yep. Let's check our last one in here. We have 1 that can go to 2, or we could have done 1/2 could also go to 2. It's just easier to do 1 to 2, which is why I'm choosing that one. To go from 1 to 2, we are multiplying by 2. To go from 6 to 12, we also multiply by 2. So yes, they are proportional. Okay. Now, a lot of that, what we just went over, was review from 6th grade, except for maybe adding in some fractions. Now we're going to learn the 7th grade piece of proportions, which is going to make your life a lot easier in certain situations. Okay, we need to talk about the vocabulary word cross products. Okay, in a proportion, A over B is equal to C over D. Products A and D, oops, sorry, are cross products, and B and C are also cross products. Okay, they're called cross products because they are across from each other in that proportion. Do we see that? Okay, so the cross products of a proportion are equal. Okay, so what this means. Here in this proportion, we see that 2 and 6 are cross products. So we cross products, meaning multiplication. So if we take 2 times 6, we get 12. If we take our other cross products, 3 and 4, and we take 3 times 4, also equals 12. Okay, so if two ratios are proportional, their cross products will always be equal to each other. Okay, so this is just showing it in algebra terms. A and D, A times D is always equal to B times C since they are cross products. Okay, obviously where B and D are not zero because you can't have a fraction with zero on the bottom. Let's try some examples. In this example, we are going to see why using cross products can really make our life a lot easier sometimes. Now remember, when we're solving these examples, we can use a calculator as long as they have decimals and not fractions, unless we convert those fractions to decimals. So we are going to be solving a problem in two different methods. Our first method is using something that we already know how to do, which is making a unit rate. Okay, our method 2 is going to be doing those cross products. So you swim your first 4 laps in 2.4 minutes. You complete 16 laps in 12 minutes. Is the number of laps proportional to your time? Okay, so our first one is 2.4 minutes to 4 laps. And remember, I could have always put 4 laps over 2.4 minutes as long as I use the same unit on the top and bottom in my other one. So here, since I put minutes first, I have to put 12 minutes and 16 laps. Okay. I want to know, are those two equal? Okay, well, the way that we're going to do this first is by comparing unit rates. So we're going to take 2.4 over 4. Okay. And we're going to find out how many minutes it takes to do 1 lap. So I want 1 lap here. Okay. Now I have to decide, how do I go from 4 to 1? Well, I'm getting smaller, so I'm dividing. Remember, with ratios, we're always multiplying or dividing. So I'm dividing by 4. 4 divided by 4 is 1. So I'm going to do the same thing on the top. So in my calculator, I'm going to put 2.4 divide by 4, and I'm going to get 0.6. Okay, I'm going to circle that so I remember that for later. Then I'm going to take my second one. So I have 12, oops. Why is that red? I have 12 minutes for 16 laps. Again, I want to get it down to 1 lap. So I'm dividing, because I'm getting smaller. 16 divided by what is 1? Well, 16 divided by 16. Okay, so I'm going to take 12, do the same thing on the top, 12 divided by 16. And I get 0.75. Okay, so 0.75 minutes per 1 lap and 0.6 minutes per 1 lap. Are these two proportionate or proportional? No. Okay, if they were, these would be the same. Okay. Now that was kind of a lot of work. Okay, so I'm going to show you how using these cross products can really save you some time. All right, so we are going to, first thing we're going to do is set it up same way we did up here. Okay, so we have 2.4 minutes over 4 laps, and I have 12 minutes for 16 laps. Okay, and I'm making sure that if I have minutes on top over here, I have minutes on top over here. Same with laps on the bottom here and laps on the bottom here. Okay, we are going to use our cross products. Remember, cross products are opposites in this proportion. That was supposed to be red. Okay, opposites. Oh my goodness. Sorry. Okay, so cross products are 4 and 12. So 4 times 12 should be equal to 2.4 times 16, which is our other cross products. I'm going to use a star here since I have a decimal. Okay. So now all I have to do is use my calculator and do 4 times 12, which if we don't already know, 4 times 12 is 48. Okay, and that should be equal to 2.4 times 16. So now we can take our calculator and take 2.4 times 16, which is 38.4. Since these are not equal to each other, they are not proportional. Okay. See how that was a lot less work than doing the unit rates? Okay, so sometimes it'll be faster to do other methods than cross products, but this is the most universal way of solving proportions that we know. As always, if you have any questions, please rewind or write them down in your margin over here or wherever you have space on your paper so that you can remember to ask those in class tomorrow. Otherwise, we will be working on our big ideas tomorrow.